This is Take 5 with Bentley, Nevada. In the studio again today with me is Tanya Woods, and I'm going to refresh my memory. Tanya, you are the Global Product Compliance Leader. Lead a pretty good-sized team across Bentley, Nevada, and as we discussed previously, the team needs to be pretty substantial because there are thousands of certifications that have to be obtained and then maintained. And Bentley does, it sounds like not just a good job, but you've actually gotten better over the last decade or so. It's just doing this with excellence. And an earlier episode, you mentioned something that took me by surprise, that the Orbit 60 is basically been launched concurrently with those approvals. And that is kind of a first in my world. I don't think I've seen that happen before.
It is the first time we've done it.
Yeah, well, kudos to you and your team for that. That's a big deal. We were talking a bit offline, and I'd like you to kind of expand on how you see the approvals landscape changing. People tend to think it's static, but it's not. And you mentioned that standards are constantly going obsolete and being replaced with newer revisions and things. So that in itself you have to keep up with. But maybe some of the philosophies regarding this are changing as well.
Yeah. So over the last several years, probably 8 years or so, we have had several changes within our protection concepts. So for those that are out there familiar with the older Bentley Nevada 3500 monitor, we had several we called non-incentive outputs. So it had a little mark that was a lowercase n with a capital L. And back in 2013, I want to say the IEC standards committees moved that NL protection concept out of the 7915 standard and obsoleted it. So that doesn't exist anymore. They did move something very similar. They copied and pasted big chunks of that over into the intrinsic safety standard, expanded intrinsic safety to include a new protection method called IC, which is kind of a zone 2 intrinsic safety protection method. We've had changes in the NA, which is a non-arcing, non-sparking kind of zone 2 protection. That one went obsolete in, I believe, 2015. And they moved that one over into an increased safety protection concept and expanded that. So now you see an EC mark that's on the newer equipment, such as Orbit 60.
For those who may not be familiar, there could be people listening that are brand new to this whole topic of hazardous approvals and hazardous areas. And there's really kind of two main schemes globally. There's a zone concept and there's I guess you'd call it a class and division concept. Why don't you talk about the zone concept first and then contrast that and tell us where those are used?
Sure. Yeah. So the zone concept, you've got basically 3 zones: zone 0, zone 1, and zone 2. Zone 2 is basically defined as having 10 hours of hazardous gas that's permitted in a year. So you're thinking if you have a fault that occurs or some maintenance where maybe there's a relief of some gas or something for a brief amount of time. Zone 1 is normal to have it there, and it's allowed a little bit more. I think I want to say it's 1,000 hours per year. And then zone 0 is normal operation. There is hazardous gas present 24/7.
Okay.
And on the class and div stuff,
Yes.
that's primarily for North America. And it's where they have class 1 div 2 is synonymous with zone 2. I would say you have the same amount of hazardous gas that's permitted to be present in a year, which is at 10 hours. And then it skips over into class 1 div 1, which is synonymous with zone 0. It's present all the time. So you basically kind of skip this zone 1 concept.
If I understand correctly, in a zone 2 or a div 2 area, the hazardous gas that could get ignited, cause an explosion, it's not present most of the time. So getting an approval for that area is not as stringent because the likelihood the gas will be present concurrently with a fault in an instrument is pretty low. You have to have two faults, I guess, for there to be an explosion.
Correct.
But when you get into the Div 1 or Zone 0, Zone 1, now it's much more likely that gas would be present, and you start multiplying probabilities. The probability of an explosion is higher, so I guess the way they inspect and certify that instrument becomes a lot more stringent.
It is way more stringent.
Yeah,
Yeah.
yeah. Are there very many products in the portfolio that only have a Div 2 or Zone 2 approval, or do they tend to move towards? I know for sensors, for example, they're out kind of where the action is. They probably always need to have the more stringent of those approvals.
Yeah, basically all of our sensors and the interface modules are Zone 0 certified,
Hmm.
and then our monitoring equipment is Zone 2.
Yeah, because it normally is going to be in some kind of a shelter where there's people, and obviously you don't want people where there's these explosive gases. So. Well, thank you, Tanya. That is helpful. Is like I said, there's people who may be tuning in and going, I don't even know what you mean by hazardous areas. So we're going to continue this conversation. There's more questions I'd like to ask about this. So stay where you are. You've been listening to Take 5 with Bentley, Nevada, a Baker Hughes business.